Welcome everyone. Uh, we welcome you to this governance webinar series. Today's session focuses on one most important role within the 3D experience platform, which is the 3D product architect. As products become increasingly configurable and customers demand more variants, organizations mostly struggle to maintain product consistency while controlling engineering effort. Product architect provides a centralized environment to define product structures, manage options and variants, and synchronize engineering designs with manufacturing. Today, we'll explore what a product architect is, why it is needed, what are its core capabilities, what are its business benefits, how it is getting integrated with ENOVIA and Solidworks, what are the best practices. So I'm Prasanna. So I'll be taking you to this webinar on 3D experience, 3D product architect. So this will be our agenda for the webinar today. This agenda will walk from business challenges through technical capabilities before ending with the real world applications. So digital product definition. We'll start off with the digital product definition, challenges in traditional product structures. So we'll see what is product architect, what is its architecture, what are its key capabilities, how is product structure management achieved using this 3D product architect role, how are configurations and variants being maintained, how is an engineering bill of material getting transferred to our management as well as your manufacturing teams. What are the benefits of having a 3D product architect role? What are the best practices in maintaining your product structures? Then we'll see a live demonstration of the role. We'll conclude with questions and any other technical clarifications which you want. So the digital transformation challenge. So why product architecture matters? The traditional challenges which we have when we are looking for a digital transformation. The bill of materials, the BOMs, are still being maintained in Excel sheets or either spreadsheets softwares. So based on these spreadsheets, which we are using to maintain the bill of materials, you have multiple Excel spreadsheets for each and every product. So you are pretty confused, which is the exact bill of material which you are looking for. So you have multiple Excel bill of materials. You have duplicated CAD assemblies. You have your product structure. You have a main assembly or a product structure. So in case if you have a duplicate of that particular assembly, so you're pretty confused which is the main assembly, which is the exact assembly which you have to generate a bill of material or create a production drawing and share it to the manufacturing team. So in that case, your duplicate CAD assemblies has a very big impact on your, it poses as a very major challenge here. Then you have manual variant creation. Your product has more than one, everything remains the same, but only one or two components gets differed. In that case, we call it as a variant. Maybe in case if you take a product, your product has the same part numbers, parts, the detail parts, everything is the same. But only thing is maybe the color of your product or the material of a product gets changed. In that case, it is not mandatory that we need to recreate the complete 3D models in our SolidWorks or any other 3D CAD which you have. In that case, what we do as a best practice, we create variants. So based on those variants, what happens is uh, we can either classify it based on material, color, etc. So you create manual variants there. This is one of the major challenge in the digital transformation. Then you have inconsistent product definitions, manufacturing errors. You don't have traceability. The traceability is very poor. You are not sure who performed the change, when was the file revised, whether the revised drawing has been transferred to the manufacturing team or not. If the manufacturing team is using the latest version or the latest revision of the drawing, so all these traceabilities are completely coming into a question mark actually. Then you have slow engineering changes. So any changes which the cross-functional teams or even the design team brings into picture, all those engineering changes are being executed in a very slow-paced manner. So many companies still maintain BOIMs across spreadsheets, ERP systems, and CAD files. This creates multiple versions of the truth. So engineering creates one structure, manufacturing modifies the another, ERP creates a third. So you have a three different set of bill of material or model or anything you want to push it to the production environment. In that case, product architect eliminates these disconnected definitions completely. So these are all the digital transformation challenges which are highly rated. Now coming to a product, which is the product architect. So what is product architect? Product architect is an ENOVIA role within the 3D experience platform. This 3D product architect role enables you to create product structures. You can manage engineering bill of materials. You can configure your product variants without recreating it. You can manage reusable components. You have control over your product evaluation completely, right from the concept design till the proto, pilot lot, till the production, mass production happens. You have the complete control over the product evaluation of the product completely. Then you can synchronize between engineering and manufacturing team completely. So to keep it crisp, think of product architect as a master definition of a product. It is merely not a CAD assembly. It defines the complete engineering product, independent of your CAD software. It does not mean you can use this 3D product architect only for the models which I create using SolidWorks. So in that case, this is how 3D product architect positions within the 3D experience platform. So as uh, you are aware, so Dassault is completely moving. We are transforming our products into this cloud-based environment, which is the 3D experience platform, and you have a cloud-based SolidWorks as well. So in that case, this 3D experience platform is capable of handling SolidWorks, CATIA. Then you can have your SolidWorks electrical files within this 3D experience platform. In addition to that, in case if your product demands certain softwares to be made, for which we have a dedicated role called connected software engineer. So you want to if you want to integrate some maybe electrical codings inside, your product demands some embedded coding to be done. So all those codings are also part of your bill of material, and all those things can be completely integrated within this 3D experience platform as well. In addition to that, you have your simulation results as well. So any product you take, you can simulate it electronically, or computerized simulations are possible completely. Uh, so based on those analysis results, you can build your 3D, I mean your bill of materials as well. So these things to your left of your screen, you have SolidWorks, CATIA, electrical, software, and simulation. So all these put together, in case if you want to create a, a, a single bill of material with all these entities combined together, that is where 3D experience product, 3D product architect comes into place. So using this 3D product architect, you can create, generate engineering bill of materials. You can configure configurations. You can configure options. You can create multiple variants of the same product. So the product architect acts as a bridge between the engineering design and the manufacturing planning. So these are the core capabilities of product architect. So the major functionalities, product architect uh, enables you to organizations to perform product structure management, engineering bill of material, variant management. You can have your product configurations. You can define which are all the reusable modules. So you have option management, product families. You can bring in your change management uh, as a part of your integration, effectivity, and traceability. So these capabilities allow organization to move from a document-centric engineering towards a model-based product definition. So your product structure management. So you by using this product architect, you can devise your product structure. So you can create multi-level product structure which has features which include your parent-child relationship. So your main assembly can have n number of sub-assemblies, and those sub-assemblies can have n number of detailed parts. It can have toolbox components. It can have any coding related in case if you are bringing in clubbing in any electrical assemblies into it. You are bringing some electrical ECAD integrations into your bill of material. In that case, uh, those electrical bill of materials or electrical components are also part of your main assembly. In case if you are bringing it as a consolidated product with your MCAD and CAD, in that case you have this parent-child relationships. You can build parent-child relationship. You can establish parent-child relationships. You can have unlimited hierarchy levels. It is not your hierarchy levels are not constrained to any particular level. You can have unlimited hierarchies. You can build assemblies. Then you can define components. You can create components. You can classify which are all the components actually. Then you can classify your standard parts as well as your purchased parts. You can classify your components. Then certain components which we do not have a valid 3D model. For example, petroleum grease is one of the product. Maybe if your product lineup demands petroleum grease as one of your line item, as a line item in one of your bill of material. In that case, we do not uh, 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 physically create any particular 3D model for that particular item. In that case, we call those items as virtual items or virtual components actually. So petroleum grease is one of your example item which I've taken it example for an example. In similar cases, you can imagine there are several other components which we do not have a. It is not required that we create a valid 3D model for that particular thing. So every product is represented as a structure hierarchy rather than disconnected cat files. So you can establish product structure management here completely. Then comes engineering bill of material management, which is our EBOM. EBOM is nothing but the bill of material which is released from the uh, uh, development team or design team or the engineering team, whatever you call it. So engineering bill of material represents the design intent and its contents. So the design intent of our design of our model or product, and it represents the uh, product structure completely. So it has CAD parts, CAD assemblies. It includes documentation. In case if there is any specifications which we need to comply, in that case you can call your specifications, softwares, any kind of electronics you want to bring in. So all these put together, you can call it as an EBOM. In case if you are using an electrical software such as Solidworks electrical, where you design all your the electrical schematic diagrams, everything completely, and you can integrate it with our 3D experience platform, and you can ensure it is also part of your EBOM actually. So what are the benefits of having this devising this EBOM is that you have single source of truth. All your revisions are completely controlled. You have controlled revisions, and you have a complete path of traceability. You can get to see who edited it, when was it edited, what was the reason it was being edited. In case if it going for a revision, uh, is this revision linked to any change actions? So what was the change action all about? So all these sorts of traceabilities are completely achievable here. You have the complete traceability path here. So unlike ERP bill of materials, so your engineering bill of material captures everything required to define the product. Then you have variant management. So variant management, to your right of your screen, you can get to see a base machine. So I just have the workflow here. So your base machine, you have a base machine. So the base machine uh, will be the same, will be built maybe based on Indian standard or any standard which you, any specification which you follow. So in case if this particular product is being exported to a country as it's to an American company or European company or to other uh, any other continent which has its own specification, in that case we'll call it as a variant. In that case, I need not change my base machine completely. I need not recreate it completely. In that case, what happens is I'll make sure that I makes that particular change, that specific change which I need to perform in my product. So in that case, I'll not recreate my product completely. I'll perform that specific change, which will comply with that countries or the continents continent standard actually. In that case, you have a base machine, you will have a North American variant, you can have a European variant, you can have an Asian variant. In some cases, you'll have customer specific variants as well. So customer will be asking for specific colors, specific materials, the dimension to be changed. Uh, so all those areas will come into your will constitute your variant management. So instead of creating multiple CAD assemblies, this product architect manages product variants through intelligent rules. So you all you have to do is you have to configure one. So your CAD parts has to be configured based on these parameters. These are some of the example parameters. Yeah, it can be your variant drivers. It can be classified based on your region. The variants can be created based on voltage, color, size, capacity. If there is any specific customer requirements and the customer is looking for that particular option to be enabled. In that case, it is somewhere something related to your customer specific requirement, which is the customer option. So by using product architect, you can you can create your variant as well, which will come under your variant management options. Then you can reuse on modular designs. So companies often redesign existing components because engineers cannot locate the reusable designs. So product architect eliminates duplicate engineering. So the benefits of reusing your existing components is that you can have your designs getting completed faster. You can have faster design, standardization, reduced cost, improved quality, and reduced inventory. So these five areas will contribute together in the area of reusing and modular design. So you can make your design faster. Standardization of components can be achieved. The cost of recreating a model completely is completely reduced. Then you have improved quality. You have traceability. The quality of your product is much more enhanced. Then you have reduced inventory so that you need not uh, uh, verify with your item master each and every time, verify against your enterprise resource planning facility which you have. So it is not required to have check your inventory each and every time. Now I'll just take you through some the real-time demonstration of the product, which is the 3D product architect role. So prior to this walkthrough, I'll just give you an insight of what has all been done as a pre-work to work on this product architect role actually. So what I've done is, so I've taken a plane manufacturing company. For example, we have many players in the similar industry, maybe for example, Airbus, Boeing, or all some of the uh, manufacturers who manufacture who are into aerospace industry, and they mainly the main concentration is on planes actually. Airplanes are being modified. So in that case, what happens is uh, I have a, a structure, a plane structure. I have a engine assembly. So all these things I've designed in my 3D software, which is SolidWorks. I've created in SolidWorks. I've stored in my 3D experience platform completely with all my revisions, approval, everything completely done. So it is a set of a standardized component, or I have it as a library component here completely. So we'll take an example here. So how is that particular? I have a set of library file which is already preset, which I've already defined. So this 3D product architect, what happens here is, I'll just take you through this workflow structure here. So by since I've mentioned, I have already have the 3D models predefined as my library. So what happens is it is not required to open my SolidWorks in case if you have an inquiry. So you want to respond immediately to that particular inquiry. In that case, it is not mandatory that you need to open your 3D software, work on this particular requirement, or to map your bill of materials against your customer's requirement. So all these things are completely eliminated with this 3D product architect role. You can just create your structures or your product structure within this browser itself. So with a valid internet connectivity and supported browser, you can create all those structures within your internet browser itself. It is not mandatory that you need to open your 3D software to design all those structures again. So in that case, what happens is I've taken an example of the customer Airbus. So let's see how this Airbus customer creates his own 3D model and how he is getting the exact bill of material. So how he is reusing this particular component. All these steps are how he is creating a variant here. So all these steps will be completely covered in this demonstration here. So let us see. So he's creating a new product structure. So via web browser completely. So he is naming his product completely. So once on creation, we have a plain assembly structure here. So within this structure, what happens is I have a predefined 3D models which I have already created. So this is my plane structure. So this is the body of the plane to which I'm going to attach an engine assembly. So this engine assembly will have a housing, it will have a shaft, it will have a propeller, etc. completely. So I can just drag and drop within this 3D product architect. I can just devise my model here completely. So so what happens is, so by using this robo, which is available within this 3D product architect, so I can move this component within the axis actually. So based on these three axes, X, Y, Z, I can make use of this robo. I can move this component at any point of time within this assembly here. So what happens is I've had uh, a left side assembly. So I need not recreate it. So what I can do is I can just reuse it. I can duplicate it. I can just reuse it. Now what happens is I'm going to create a right hand side as engine assembly setup here completely. In that case, what happens is I can directly drag and drop my robo to that exact component. I can choose which are all the list of I can choose the assembly. I can make use of the robo navigator. I can scale it. I can fix the exact position. And then it is not mandatory that I need to provide the exact structure. So I'm working on a model where I'm going to give just a temporary bill of material or a rough bill of material here completely. So here what happens is I've created a structure here. For example, I've taken Airbus. So Airbus is the leading uh, plane supplier to many of our Indian companies, Indian aviation companies such as Indigo. Indigo has a theme of blue. You take Air India. Air India's theme will be completely based on red. So in that case, what happens is, so I can create variants here. So what happens is this engine assembly, as you can, you would have seen the flights of Air India. So all those engine structures would be in red color actually. So in that case, what happens is if it is specific to any customer, I can create variants here. For example, I have this. I've created this structure completely. Now what I'm doing is similar to reuse. I can replace these parts as well. So what happens is I'm replacing with existing. In case if you know what is the part exactly, I can make it. So rather than changing the complete thing, I'll change this housing unit alone. In case if it's indigo, I have a part number with the same housing, which is blue in color. In that case, what happens is I need not recreate that particular assembly. I can just replace it with this existing structure. So in case if I'm delivering a plane for Air India, similar way, what I can do is I can just recreate this particular structure completely. So with this, what happens is you can reuse your assembly completely. You can recreate your assembly completely. Uh, Completely. Then you have an option where you can create part numbers within this product architect itself. You can create enterprise part numbers. You can bring in any sort of components. It is not necessarily a 3D models which is created on SolidWorks. You have you can bring in your CATIA models, etc. Within this. It is independent of any CAD 3D model, 3D CAD you use. It is not mandatory that you need SolidWorks tool to work on this 3D product architect. It is not necessarily the 3D model should be created in SolidWorks. It can be on any 3D modeling softwares as well. So this is how you can just simply roughly create with a bill of material within a product structure within a fraction of minutes or matter of minutes or so. Uh, so so what is the advantage of having this product architect role is that certain companies which have a dedicated design team who will be working on RFQs exclusively for inquiries and inquiry designs. This product architect is a tailor-made solution for that particular team. In addition to that, so this particular product architect role does not require any prior 3D modeling working experience as well. So even a person who is who is ready to get trained on this particular product architect role can be trained even without any dependency on the design team, who will give you a set of library files. So that particular person who is trained on this 3D product architect role can be can create designs on his own. He can build the product structure completely, arrive at a bill of material, and export this complete bill of material to an Excel sheet and hand it over to the costing team for further costing works completely. So these are the key benefits of this product architecture. So you have your improved structure management, faster development of your product development is being made faster, enhanced variant and configuration management, better collaboration across teams. You have improved change management, increased product reuse, digital continuity across life cycle, better bill of material management, improve traceability and compliance, and reduce time to market. So these are the best practices uh, for having a product structure configured. So the successful implementations depend on disciplined product architecture and governance. So build modular products. You can standardize your components. So any component which is getting reused across your projects or product lineups. So all those components can be standardized. You can minimize your duplicate parts. So once you're bringing in your library concept or you're standardizing your concept, there is no need of duplicating the part each and every time for each and every product lineup which you have. So in that case, you can minimize your duplicate parts. You can use configuration rules. You can have product families. You can manage your product families. The product families can be your CAD family. It can be your mechanical CAD family. It can be your electrical CAD family. It can be your software oriented structures completely. So all your product families can be completely managed. Then you have to implement change control, integrate your CAD earlier, then connect your manufacturing. So these are the best practices for having your product structure compliant. So your summary. So a product architect is more than a bill of material management tool. It is the foundation for digital product definition across engineering, manufacturing, and enterprise systems. So these are the key takeaways. This is a single source of product definition. It has intelligent engineering bill of material generation capability. You can have product configurations. You can you can bring in your product configurations. You have variant management where you can create n number of variants for each part. Then you have synchronization with your manufacturing teams. You have enterprise change control. You have improved engineering productivity. So you can just scan this QR code, which will take you to our Linktree landing page, where you can find the links to all our social media sites, where you can follow us for our product information, updates, any upcoming webinars and seminar schedules. Everything will be published there. You can get to see all our updates there. So you can kindly connect with us and you can subscribe for more timely updates.